Next operation we are going to check will be get all words from try. The first previous operation was insert just to confirm right whether it is correct or not. We can implement the next operation get all words. That means will insert one word and call this function just to check if it is correctly implemented or not. So logic of get all words is very simple. What you'll need to do is just recursion, right? Because we'll be needing to traverse through all the directions. Yes. So we'll be needing to use recursion. And after this, our output is expected to be this. All the words that I have inserted, all the words. This is what my output should be. It can be in a list. Yes. So now recursion is very simple, is it right? Because we'll be needing to go to all the directions and just while you are going, keep track of current word. That means what will happen is let's say we are using a temporary variable. Whenever you reach at a point where whenever you reach a cell which is not null, that means that is active. That means that character was inserted. You'll simply keep track of that. At this point, your temporary will be A. When you come to C, your temporary will be AC. You will come to E, your temporary will be ACE. When you just go one step below, you will here see there is a node ended is true. That means this path gave you one word which is ACE that wherever this is ended now. Yes, that means you'll include this in your string. After this, there's nowhere to go. Is that right? So you'll backtrack. Yes, that means you'll go to another way. Here you'll say your temporary is now AB and you'll continue wherever your temporary string is, whatever your temporary string is. And at that point, if ended is true, that means you'll keep track of that word. Yes. Now let's look at the logic of recursion. If you just focus on here, right? In root, there are only two indexes. 0th index is active and 1st index is active. How can you check these indexes are active or not? Yes. So simply those should not be null basically. Is that right? Because we said null means inactive cell. That means that word was not inserted. That character was not inserted. No. So to make recursion, you'll simply say whichever is not null, first append that character and go in that direction. Yes. Now let's see how exactly it will be. Of course, first thing we'll be doing is have a list of string declared globally or in the parameters answer, and void is a return type because we don't need to return anything. We just need to store it. Let's say get all words is what we have to complete. Yes. Now. So we know there are certain parameters we want. So first parameter is the root itself, root. Second parameter is a temporary string temporary, and this is it. Is it right? We can make it work it out. So first point is if at all while traversing, our route is ended. Is that right? While traversing, if a route is ended, that is the first condition we should be writing. We'll be writing that. That is easy. But now, if you first have to traverse, right? If you have to traverse, you should be going to all the indexes. What are all the indexes? Indexes are from 0 to 25. Yes. So let's first do that. So for int I equal to 0, I less than 26, I plus plus. What do you need to check? In root children array, you need to check whether ith index is null or not. So you'll simply say if root dot children of I, if it is not equal to null, if t is not equal to null, you have to do certain things. What are those things? We said if a is not null, we have to add a, we have to append a in the string. So first, let us say we want to get character. Character current ch will be nothing but now you have I, right? You'll have 0. How will you get a if you have 0? You simply have to map it simply now. You'll simply say whatever your I is, just add a, which is nothing but ASCII value, and give me the character. Yes. Now after this, what we have to do, we simply have to make the recursion call. What we need to do from A, we need to go to all the directions of A now. To do that, we know we have to make a recursion call where you'll simply say get all what is the function name. Where root, it will not be root now. You want to go to children's of root, is that right? So it will be simply root dot children of I, comma. Again, we said we have to append it. It will simply be te dot ch current character, and we are done. We are done. Yes. Now, while traversing, you will from A, you will come to C, you will come to E, you will come to this point. At this point, you don't need to go any further. Or do we need to? Think about it. Yes. Whenever ended is true, we'll capture this word. That is totally fine. But question is, do we need to go beyond this? Do we need to go below this? In this example, your answer will be no. But what if I tell you that Bagger. Yes, this is also another word. One word is bag, one word is bagger. Yes, I'm not sure if such kind of word exists, but just think about it. That means even if you come through this word and if you check till G, I have one word, you cannot return back, is it right? Because other following that word, other words can also be there. Yes, so this thing you'll have to take care that at all any point, if root dot ended is true, what you'll do, you'll simply say in answer, just add a temporary but never return. You'll only return if all the words are completed. This is what the implementation is. Yes. No. Let's try to actually implement it so that we don't have any back thought that whether it's working or not. So I wrote a template where just I'm reading the operation code and just I'm inserting it. Inserting logic is just the same. I'll show the inserting logic. So this is what it is it right? I have taken one temporary root as discussed. I'm going to every single index, and if it is null, I'm creating a new, or else I'm just marking the current node as visited. I'm marking as show after the string as ended, and we are done. If operation 4 is there, I'm doing a couple of things here. I have taken one li, I have taken one temporary string as I said, and I'm calling the function get all words. Yes, let's see what exit logic for that is. Whenever the root is null, we are saying return. Yes, that means even if you don't put it, it is totally fine. This is the case where we did not inserted any word, and if you're trying to get all words. Yes, that is this case. Now, if root or dot ended, if it is ended, we are saying add the current temporary in your answer list, or else if it is not null, if any cell of current root children array is not null, add the current character and go on searching in that node now. Is it right? Now, this is the logic that I implemented. Let's see. Let's try by running it. I have implemented it. So I'm saying there are 5 operations. First operation is I'm inserting a short. Second operation is I'm inserting a word abacus. Third operation is I'm inserting apple. If I type 4 and if I run operation number 4, see what is happening. Whenever I run operation 4, it should give me all the inserted words. Only then we can confirm our insertion is true. And it is that right? So, yeah. So insertion and get all words are making sense.